Hello, everyone. We're really excited to have you here today. I'm Nolan, and I'm the product manager for Firebase App Quality.
And I'm Ali. I'm product manager on Firebase Performance Monitoring.
So today we're going to talk to you about how you can build great app performance with Firebase and our new tool, Performance Monitoring. So our story today starts with Jane. Jane is the lead mobile developer for an e-commerce startup. And her team have been spending the last 6 months building the iOS and Android versions of their app. And now they're finally getting ready to launch. And Jane knows it's important to release a high-quality app if she wants happy customers. In fact, we did a recent analysis of Google Play Store reviews, and we saw 50% of all one-star reviews mention stability and bugs. So the data here really speaks for itself. If you have a slow and crashy app, your users will notice. Now, since Jane is focused on building high-quality apps, she's using Firebase. And Firebase is going to let her test her app on a variety of devices before launch, but she knows no amount of testing will catch all the issues, so it's important that she monitors her app in production after launch. So we're going to do a quick review of testing and crash tools, and then Ali is going to do a deep dive on performance monitoring, which is why we're all here today. Now, since performance is a conflated term, I want to point out that when we say performance monitoring, we're not talking about business performance tools. Firebase does have business performance monitoring, like Google Analytics for Firebase, that'll give you insights into your revenue, conversion metrics, and user acquisition channels. But today, we're going to focus on monitoring the code performance and speed of your application. So let's take a look at how Jane is going to use Firebase to ensure a high-quality app. Now, the first thing Jane needs to do is test her app before she puts it in the hands of her users. But so far, Jane hasn't had any time to write any test scripts, and she's only tested on a few handsets that they have in development. That's where Firebase Test Lab saves the day. So Firebase Test Lab is a device lab running on Google Cloud that has physical and virtual devices. And Jane can choose from a combination of devices, OS versions, and even up to 172 different languages to test her app with. And we're continuously adding new devices that are popular from around the world to the test lab. In fact, today you can even get Developer Preview O running on a Pixel device in our test lab. So you're probably thinking that access to all of these devices is great, but if you don't have any test scripts and Jane doesn't, then what's she going to do about it? Well, this is exactly why we built Robo. So Robo is an intelligent app crawler that will explore your app and attempt to find crashes and layout issues without writing a single line of code. Jane simply uploads her APK and selects the Pixel running Android Developer Preview O. And then Robo's going to go through and crawl her application. It's going to record a video of everything that it does, capture screenshots, captures the device log, and even stack traces for any crashes it might find. And this lets her sanity check her application on a real device that she doesn't have without writing any code at all. Now, Robo also powers the pre-launch report in the Play Developer Console, which is available at no cost to all developers using the alpha beta channels. Yesterday, we launched a new feature in Firebase Test Lab that lets you see performance metrics for all of your test runs. So whether you're using Robo or your own test scripts, you can get insights into CPU, memory, network, and frames per second. And the really great thing about this feature is that the metric timelines are synced with the video. That means if you see a CPU spike or a drop in frame rates, you can click at that point in the timeline. It'll seek to that portion of the video, so you can kind of diagnose and see what's happening. Now, it's important to note that Firebase Test Lab gives you performance insights before you launch, and performance monitoring, that we're going to talk about for the bulk of our discussion today, gives you insights after you launch in production. So Jane knows that no amount of testing that she does is going to find all of her issues, and she really needs to keep a pulse on her app in production. And she's particularly interested in finding crashes and severe issues, so she's going to use crash reporting. So last year at I/O, we announced Firebase Crash Reporting, And developers loved how easy it was to get alerts into new and regressed issues. And not only that, but stack traces to help them identify the problem. Now, when we built this product, we really wanted to help developers not only identify the crash, but also reproduce the crash. So we integrated with Google Analytics for Firebase, so you can see exactly what your user was doing prior to the crash. So you get an event log from everything in your analytics prior to the crash to see how you can actually replicate this locally. And this year, we're really excited with some even bigger news. So Firebase has joined forces with Fabric, and we're working really hard to bring the best of both platforms together. We're really excited about Crashlytics in particular from Fabric because it's the leading crash reporting tool on the market, used by over 500,000 developers. And we're going to be bringing it to the Firebase community. That means you're going to get the entire Crashlytics experience right from the Firebase console. So if you're thinking about integrating a new crash reporting tool, we recommend Crashlytics. But if you use Firebase crash reporting, you don't have to worry. We're going to continue to support that, and we'll upgrade you seamlessly when we're ready. So Jane's an early adopter. She wants the latest and greatest. She's going to use Crashlytics and install the Fabric SDK. And finally, Jane wants to understand what parts of her app are slow and why. So these are often the hardest problems to diagnose and even harder in production. So she's going to use Firebase Performance Monitoring. All right, so let's get to the fun part. In this demo, we're going to see how Jane uses Firebase Performance Monitoring to progressively enhance her app over the course of a month. In some cases, Jane's going to use out-of-the-box capabilities like network insights and app startup time. And in others, we'll see how she uses custom instrumentation to find a solution. And with that, take it away, Ali.
Thank you. All right, so we'll get back to Jane in a second. But before we do that, it's probably a good idea to mention why we build Firebase Performance Monitoring. And quite simply, the problem we're solving here is that the world has a short attention span. We already know this from the web. The longer your page load takes, the more likely for users to bounce. But with mobile, we're actually seeing this just as much, if not even more. As a matter of fact, 60% of 5-star reviews we see on Play make a mention of speed, design, or usability. So we know that good performance is critical for app success. The other reason we were excited to build performance monitoring is that it turns out to be an interesting problem from a technical perspective, and one that is more challenging than doing the same on the web. With the web, you have page loads, and page loads tend to map quite well to user actions. So anytime you get a performance metric, you kind of have a good way of mapping it to what the user was doing on your website. Mobile, on the other hand, is a bit of a black box. So even if you have performance metrics, it's a difficult job to understand what was happening at the time you took that metric. So we set a challenge for ourselves to build something that not only gets you a lot of data, but a lot of data that is contextual. And the result was Firebase Performance Monitoring. We were super excited to announce it yesterday in the keynote. It's available to everybody in beta, and the SDK supports both iOS and Android. And as we built this SDK, we wanted to accomplish a couple of things. First of all, we wanted to make it super simple to install. So if you're on iOS, you get the CocoaPod. If you're on Android, you pick up the Gradle plugin, and off you go. And even if you do just that, you get a lot of value out of the box, data like network and app start, and we'll see an example of that. But if you want to instrument things that are specific to your implementation, we also give you SDK APIs that allow you to do just that. And that's the SDK. The other part of performance monitoring is a beautiful console that we built to allow you to dig into the issues and understand performance metrics from the point of view of your user. So going back to Jane and the app that she builds, and this really generalizes to any kind of app out there, we think that performance issues that can impact you as a developer fall under one of two buckets. The first one has to do with your app code performance. So this is things like what kind of delays your users see as they interact with the app, or how much frame drops they see in the animations, and so on. And to monitor that, we built a feature called traces. The other category of issues is about network activity between your app and the backends that it uses, whether it's your own backend or backends of third-party SDKs you have in your app. And for that, we monitor network requests. So let's get started with traces first. The easiest way to define a trace is it's a performance report between 2 points in your app. So imagine you have a record button and a stop button. And in between these 2 points, you just pick up metrics, right? So these 2 points can be anything in your app, anything that you care about and you think is worth monitoring. So it could be something like the time between the user taps on one of the shoes until they see the full product details page. It could be as fine-grained as a database fetch to get a piece of string and put it on the screen. Or it could be as long as a full checkout flow, right? It could be between the time the user taps on the checkout icon until they fully purchase the items. It's really up to you. All you need to do is create a trace name or a trace object, give it a name, start it, and stop it. And that name you give it becomes your context. So now when you're looking at metrics, you understand what was happening in the app at that time. In terms of metrics, by default, you get the trace duration, so how much time took place between the start and the stop. So essentially, you can use it as a timer, but it's actually more than that, because you can attach custom metrics using our counter API, which you see an example of here. So here, think of any example of countable events that are relevant to your performance. How many times you call the local disk, how many times you call the GPS, how many times you dropped a frame, how many times you made a network call, and so on. Any one of these events, you can just give it a name, you can count it, increment it, and we'll tally up those events and report them as custom metrics attached to your trace. So this gives you an idea on how to instrument your own traces and counters. But even if you don't do this and just install the SDK, you still get a few out-of-the-box traces. The most important one being app start. This is the time between the app code starts loading until the app is responsive to the user. And we also have a trace that monitors the foreground session, so anytime the app is available to the user. And we do the same for the background as well. And that's traces. Nice and simple. All right. So network is even more simple because you don't need to write any code. It all comes out of the box. We'll monitor HTTP and HTTPS requests that your app makes between the time they are sent from the app until the response is fully received. And when we do that, we report a bunch of metrics, including response time, including the request and response payload size, and success rate, where success here means any request that comes back with an HTTP code that is not a 400 or a 500. Cool? And then for any of these metrics, network or traces, you have the ability to slice and dice the data by the app version, which device the user was using, which country they were in, and so on. And this is really helpful to eliminate variables and to understand the contributing factors for some of these issues. Actually, the best way to explain this would be to get back to Jane and talk about how she used performance monitoring over the course of 4 weeks to get rid of a lot of performance issues and fix them very, very quickly. So we're going to do this by monitoring what she does on her iOS app. And so far, the only thing that Jane has done is install the performance monitoring SDK and use the out-of-the-box capabilities. So she did not write any code. Okay? So on the first week, Jane gears up for the first major release. So far, she's been building a bunch of experimental releases. And this is the week she releases version 1.0. And the e-commerce app she works on operates in the US and Canada. And we're off to a rocky start. We have a bunch of 2-star reviews. And the complaint that we get from users seems to be about app start. It's just taking too long. Some people are getting frustrated and are giving up on the app. So the first thing she does is jump into the Firebase console. You can switch to the console, please. Perfect. And she checks out the brand new performance section in Firebase. And the first thing she sees is the dashboard tab. So this here gives you high-level data from both traces and network, aggregated for the app. And keep in mind, she hasn't written any code, so all the data you see here is out of the box. So let's take a look and see what we see. The first card here gives us the most frequent traces. So in this case, the out-of-the-box ones, app in foreground, background, and app start. And app start has a median latency, or duration, of more than 3 seconds. So that does seem to be a bit high. We'll get back to this. But let's keep going. Next one here shows me the network success rate. Now, we always want this to be 100%, but when we start seeing 400s and 500s, that line goes down, and I can actually hover over some of these points to see what the success rate for an individual day was like. Next card here is network latency by country. And since we only have data from the US and Canada, we see that on the map. And if I hover over it, the US is about 1 second, Canada is even less than that. So we're good on this one. Everything is within normal ranges. The next one here is a card that gives me the breakdown of network volume based on MIME type. And you can see that the blue here is represented by images, which makes sense. It's an e-commerce app, and there's a lot of images here, so it makes sense that the majority of my network volume is images. And the last card here shows me a comparison of app start time version over version. Now, this is interesting here because I see that v1.0, which is the latest release Jane just put out, has a much higher app start duration than the previous ones. So by the way, what you see here is the dark dot is the median, and then the lighter blue line around it is the range of percentiles from 5th to 95th. And I can actually hover over it and see what it looks like. So, sorry. I can see that my 95th percentile here is about 7 seconds, which is very, very high. Now, this is useful information, and so far this is a strong indication that something went wrong in this version. But how do I know that there's no other contributing factors? If I actually click on View App Start Duration, I get a breakdown of this metric by different slices, by different dimensions. So I see how App Start Duration compares version over version in different devices, countries, and so on. And this allows me to understand if there's anything that stands out. And again, you see the median, and you see the percentiles around it. So I already know that v1.0 is much higher for App Start duration. If I look at device here, I can see that the iPhone 6 is a bit higher, but this is expected. It's an older device. It's going to be a bit slower. So let me keep going here. Country is comparable. OS level is kind of comparable. So is carrier. OK, so at this point, Jane knows that to fix the App Start issue, she has to do something about v1.0. So that's enough information. If we jump back into the code, get the slide, please. Thank you. She takes a look and realizes that there's a blocking call here to load a bunch of cached items. There's no good reason for this to be made as a blocking call. So she switches this to an asynchronous dispatch, and that takes care of the issue. Cool? All right. So she patches up the fix, releases version 1.1, and this is the end of our first week. Now, the second week is a pretty interesting one. This is the week we expand our operations to India, which means new users and new behavior. So the first thing Jane does is jumps back into the console, and she takes a look to see how things are. So first thing she looks at is app start. Seems like the median is a bit down. That's a good sign. And if I scroll down here, I can see that 1.1 has a much lower or shorter app start than 1.0. So it looks like we fixed this issue. This is great news. The bad news is that now that we have some data from India, it seems like network latency is pretty high. If I hover over it, I see a 7.2-second median latency. So this is definitely high. So how do I investigate this? I'm going to go ahead and click on the Network Requests tab. And when I do that, I see a bunch of URL patterns, right? I see a call to an analytics service. I see a bunch of back-end services for fetching images for the product, fetching product details, adding something to the cart, and so on. And by the way, anytime you see one of these asterisks, it means that there's a dynamic path segment in the URL. So it could be something like an ID. What we do is collapse all these IDs into the same URL pattern. So when you see a metric, you see it based on the level of the back-end functionality, as opposed to looking at individual URLs. All right. So for each one of these URL parameters, you get the response time, you get the success rate, and you get how many requests we have actually collected. And if you look closely here, you see that there's a couple of warning icons. One of them is complaining about latency here. It says that we recommend to keep our response time under 2 seconds. And the other one says that my success rate is below 90% and that this is problematic. In fact, I can see that my success rate here is 87% for the checkout service. Now, this is unexpected, so I need to investigate a little bit more. So I'm going to go ahead and click on the URL, and I get a bunch of metrics. We talked about this. So you get the response time, payload size, and you also get the success rate. And if I click on View More, not only do I get a breakdown of the dimensions like we saw for the trace, for the App Start trace, but I also get a card here that gives me a breakdown of 400 errors and 500 errors. So this way, I can understand what caused the failure. So I can see that out of my approximately 12% failures, a very tiny bit is 400 errors. The majority of the errors are 500. including 500, 503s, 502s, and so on. And the vast majority of those is 500. I can also scroll through the dimensions to see if there's anything that stands out. So far, it seems like my success rate is pretty evenly distributed. But if I look at country, I can see that all these failures are coming from India. The success rate is 0. OK, so this gives me a lot of information. It's 500 errors that I need to fix, and they are happening only in India. So, and by the way, I can switch to the overtime version of this data. I see the same metrics only by time slices, so I see how they change over the last 30 days. And I can see that my 500 errors in blue here spike around the same time Jane released her operations to India. So that confirms the theory that I had. Great. Now, if I click back to network and look at the other warning that complains that my latency is too low or too high, I think that this has also something to do with my users from India, because I didn't see this before. But the way I can confirm this is by filtering by the country. So here, any of the dimensions that we collect, you're actually able to filter by them. So I'm going to go ahead and choose country, India. And now I see the same data only filtered by Indian users, and I can see that the image service is way, way, way higher. It's about 20 seconds on median. That's obviously something we need to fix. All right. So this is a lot of information. We have a couple of problems we need to fix here. So we'll switch back to the code. And Jane takes a look at the 500 server error. In this case, she realizes that she mishandled the Indian locales. Hindi, which is the predominant locale in India, was misspelled. So that's an easy fix. This is good. She goes ahead and fixes that. And for the slow response time, she realizes that the way she's getting images for those products is using her own service, and the actual server sits in the US. Now, this was fine for North American users, but for Indian users, it's not going to cut it. So what she does is instead use Firebase hosting, which gives you a CDN and takes care of edge caching for you, so you don't have to worry about that. She goes ahead and puts the assets on the CDN. She switches the URL call to call the Firebase hosting service, and that takes care of that issue. And she packages up all these fixes, releases version 1.2, and that's the end of week 3. Now, week 4, sorry, that was the end of week 2. Now, week 3, we're seeing things starting to get better. So we're seeing 4-star reviews. But there's one issue here. There's this Indian user, his name is Nitin, and he seems to be a bit upset that he used 50% or 50 megabytes of his data plan on this app. Now, keep in mind, data is expensive in India. So there's something that we can fix about this. So Jane gets concerned about this, switches back to the console to see if there's anything that can help her with that. And she realizes that we have this card here that gives you a breakdown of your network volume by MIME type. And we already know that the breakdown tells us that the vast majority, or at least the majority of our data, is images. And this pattern hasn't changed in the last few days, it's even more, actually. So at this point, she realizes that she has a problem. All these images she fetches in the app, she never stores them locally. She doesn't cache them. And this is a problem for e-commerce apps. So imagine that you're a user on one of these apps, and you want to compare a bunch of products. You're likely to switch back and forth between the same pages and fetch the same images. There's no good reason to keep going back to the CDN to fetch it every time. So she realizes that she needs to add that logic. So let's switch back to the code. Now, the first thing that she needs to figure out is the cache size, right? We're going to essentially build a cache on the local device. And she starts by doing something like this. She hard code the cache size to 20 megabytes. Now, this is OK, but there's a problem with this. What if you realize a couple of days later that this is not the optimal cache size, and it should be 25 megabytes instead? Now you have to redo the same thing. You have to release a new app version. And you have to wait for people to pick up the latest app version. It's inefficient. Instead, what she does is she uses remote config, which allows you to set a parameter in the console. You can set the value for it, edit it, and you can just publish it, and it gets picked up by your app. So this is a much, much better way to do it. So she switches to the console, and now we're using remote config instead. We're going to add a new parameter, give it a name, cache size, and give it a value of 0 to start with. So it's as if we don't have any caching. Okay? We'll add the parameter, publish the changes, and that was it. OK, so this parameter is set. Now, switching back to the code again, instead of the hard coding, Jane changes the code so that she reads the value from remote config. And that takes care of the cache size. We can tweak that later. Now, she adds the logic to do the caching on the device. And that takes care of the implementation of the feature itself. But how do I know that this is running efficiently? I need to monitor this. So what Jane does is create a custom trace in this case. So she creates a new trace, gives it a name image fetch. She starts it before this logic, stops it after. And then within the caching logic itself, she does a couple things. She creates one counter, calls it cache hits, and this gets incremented anytime we find the image we're looking for on the local device. And then she creates another counter, calls it cache misses, and this gets incremented anytime we don't find the image we want on the local device and we have to go get it from the CDN. Okay? So this takes care of the monitoring. And this is all the code that she needs, really, to monitor this. So she goes ahead, packages up the latest code, and ships version 1.3. Now, week 4, we want to check on things. So Jane goes ahead and jumps back to the console. Great. We can see that India is not slow anymore, so this is fixed. But since we just added a brand new trace, we'll go ahead and click on the Traces tab. So here I see the ones that come out of the box, but I also see the image fetch one, which is the brand new instrumented trace that Jane added. So I'll click on this, and I get the duration metric, which I always get, but I also get the counters here as metrics. So cache hits and cache misses are there, and as we would expect, there's no cache hits because the cache size is 0. So Jane goes to remote config and now edits this value, makes it 20 megabytes instead, updates it, publishes the changes, and she lets a few hours go by so that this change is propagated to the phones and that we have enough data on performance. And then when she switches back, this 0 here for cache hits, when she refreshes the next time, is not a 0 anymore. We're starting to see cache hits. And in fact, if I switch to overtime, I can see that my cache hits are going up, my cache misses are going down. So this is the direction we want to take. And just like that, she starts tweaking the value of the cache size to find the optimal use for most of her users without having to ever release a new app version. Can you switch back to the slides, please? So people start noticing this, and they notice that the performance is getting much better, and they start sending amazing reviews. And Jane is so happy. Look at this smile. OK, so hopefully by now, you get an idea of why it's important to use performance monitoring and the kind of things that you do with it. And I think one of the key advantages to having something like this is that it makes you aware of your blind spots, the kind of issues that you have in your app that you wouldn't necessarily expect. And this is something that we see with our partners all the time. I'll give you an example. This one is based out of China. WPS Office is a popular office productivity app in Asia. And they use Firebase performance monitoring, and using the network monitoring feature, realized that one of their ad banners takes more than 2.4 seconds to load, which is way higher than they had expected. They optimized this by 20%, and they see an increase in their click-through ratios by 3 to 5 times. Think about this kind of impact. All they had to do was install the SDK, and they got this much increase in CTRs. I'll give you another example. Kaskus is a chat app based out of Indonesia. They use performance monitoring and realized that one of their biggest performance bottlenecks is the opening of the chat window. It took 0.5 seconds in some devices. That's something they did not expect. They optimized it, and because of that, they have a much better user experience. So this allows you to do things like this, but it also opens up the possibilities for things that weren't possible before. This is one of my favorite examples. İzlisene, which is a video app based in Turkey. Even though they haven't been using performance monitoring for a long time, they already have customized treatments for their users based on the combination of device and OS level. This is the kind of thing that would have been difficult in the past, but because of the insights and the deep insights you get in the console, you can do this kind of things. And there's many other examples. We've been actually working with our partners from around the globe, big apps and small apps, to make sure that what we have here is useful and is something that is going to add value to your everyday development. And that is it. So recapping here, we talked about app quality today. We talked about why it's so important and why we deeply care about it in Firebase. We talked about the test stage of things and how you can use Test Lab for Android so that you can squash these bugs before you get out into production. We also talked about how you can use crash reporting in production and keep an eye on stability. We shared some exciting news about us joining forces with Crashlytics. And finally, we took a deep dive on performance monitoring, and we saw how Jane used it to turn around her app and go from 2-star ratings to 5-star ratings. Again, performance monitoring is available as of yesterday. Please check it out. Before I let you guys go, I have 2 requests. Go to firebase.google.com, check out the documentation on Firebase performance monitoring, get a feel of the product, and let us know. We would love to chat. And the other request is, please come visit us in the sandbox. The team that built this product is actually sitting in the back there, and they're going to be around today and tomorrow. We would love to chat. Come with your questions, concerns, comments. We would love to chat. Sounds good? All right. Thanks, guys.